Because right now, as you and I sit here in the quiet comfort of our lives, NASA is quietly preparing for a worst-case scenario. This isn't because of a looming war, and it isn't because of a natural disaster we can see on the horizon, but because of something drifting through the dark like a silent question: 3I/ATLAS. Over the past 9 days, this enigmatic object has done something that even the most seasoned astrophysicists cannot fully explain or rationalize. Before we go deeper into what that means for us, take a moment with me. Hit the like button, subscribe to the channel, and tell me in the comments where in the world you're watching from tonight. I truly want to know, because tonight's story connects every one of us under the same fragile sky, regardless of our borders or backgrounds. Now, take a deep breath, because what I'm about to share with you may stay with you long after this video ends, haunting your thoughts as you look up at the stars. It began with a tremor. It wasn't a tremor felt in the ground beneath our feet, but one in the magnetic field that surrounds our world like an invisible protective ocean. In my early career, when I was a graduate student at MIT, poring over satellite telemetry and endless lines of data, we used to joke that the Earth's magnetic field is the heartbeat of the planet. When it flutters, you pay attention. It is our first line of defense, our silent guardian. And 2 weeks ago, it fluttered. Solar physicists initially thought it was a minor geomagnetic ripple, a curiosity, a footnote in a quiet week of solar activity. But when they overlaid the event with the tracked position of 3I/ATLAS, every joking smile in the lab evaporated instantly. The disturbance matched its trajectory perfectly, as if something about this interstellar visitor, something deep inside it, had reached out and pushed against the solar wind in a way we have never seen before. But that was only the beginning of the anomaly. When NASA's Solar Dynamics Observatory ran the data through their models again, they found something far more disturbing than a simple magnetic ripple. They detected a subtle phase shift in the solar plasma directly in the object's path. This wasn't a flare, and it wasn't typical turbulence. It was something we have never observed from a comet, an asteroid, or any known interstellar rock. It was almost as though the sun itself reacted to the presence of 3I/ATLAS, vibrating in resonance with its passage. That is when the phrase worst-case scenario preparation first appeared in internal memos. You must understand something. NASA does not use that language lightly. I remember sitting in crowded conference rooms during the early days of the shuttle program. Back then, worst-case scenario was a term reserved only for events we could mathematically model and prepare for: engine failures, trajectory errors, or micrometeoroid strikes. But this time is fundamentally different, because the truth is, we don't know what we're dealing with. 3I/ATLAS is not following the behavior of any natural object we have cataloged in the past 50 years of space observation. At certain intervals, its coma brightens, not gradually, as you would expect from ice sublimating in the sun, but suddenly, as if turned on by a switch. Then, just as quickly, it dims into complete stillness. Then it shifts direction by fractions of a degree for no gravitational reason we can calculate. And now we have a new problem. NASA can no longer agree on what's happening inside it. Some believe the interior is fragmenting under thermal stress. Others believe it is stabilizing after a long journey. But the newest theory, the one that leaked from a quiet corner of a Harvard subcommittee meeting, is far more troubling. There may be an internal energy source, not nuclear, not chemical, something that behaves like a pressure wave, but without any heat signature, a kind of cold eruption. When those words first appeared in the official reports, senior scientists stopped reading. They sat in silence. Because if it's true, then this object is not just unpredictable, it's unprecedented in the history of human science. Let me explain why NASA is quietly preparing models for the worst. When an object releases energy, even a tiny amount, in deep space, it can alter its motion. But 3I/ATLAS altered its motion before any energy signature appeared. It was as if whatever happened inside it propagated outward through space-time itself before interacting with physical matter. That shouldn't be possible according to our current understanding of physics. Physics tells us that energy propagates outward from a source. It doesn't arrive before the event occurs. But that is exactly what the data shows. A ripple, then a long pause, then the eruption inside the object. Imagine tapping a bell and hearing the echo before you even touch the metal. Even now, as I say that, it gives me chills, because it suggests that 3I/ATLAS might be interacting with the fabric of space in a way we don't yet understand. This is why NASA has begun running worst-case models. Not because they believe a catastrophe is imminent or certain, but because when the laws of physics stop behaving predictably, even the smallest unknown becomes a potential threat to our infrastructure. But what exactly is the worst case? Some believe it's a hypervolatile fragmentation event, a deep space explosion that sends debris through the solar system like invisible shrapnel. Others believe it's gravitational, a localized distortion that could briefly nudge solar plasma in unpredictable ways, potentially triggering massive flares directed at Earth. But there is a third possibility, the one no one wants to say out loud, a solar response. The sun is not just a passive ball of plasma, it is a dynamic, sensitive engine. It reacts to disturbances, it resonates. And for the first time in my career, I am looking at telemetry that suggests our star may have briefly synchronized with an interstellar visitor. It was a tiny flicker, a resonance deep in the convection zone, barely measurable, but hauntingly real. If 3I/ATLAS carries a field or mass property or internal structure unlike anything we've encountered, and if the sun responds to it again, that is when NASA's contingency models matter most. The solar response can cascade, and once it begins, there is no stopping it. We are essentially bystanders to the mechanics of the heavens. Let me bring this closer to home so you can understand the stakes. Many of you watching remember 1989 and the Quebec blackout. A geomagnetic storm triggered by a coronal mass ejection shut down power grids in seconds, leaving millions in the dark and cold. Now imagine a solar event not triggered by internal solar turbulence, but by an external catalyst drifting silently through space. That is what keeps scientists awake at night. It is not necessarily the fear of disaster, but the presence of uncertainty, because uncertainty is the one variable no model can predict. During the past 48 hours, NASA and the ESA detected a second event. It was small, quiet, and almost unnoticeable to the untrained eye. A soft pulse, a signature so subtle that early algorithms dismissed it as simple instrument noise. But 3 independent observatories confirmed it. It came from 3I/ATLAS. And this time it happened without any visible activity. No brightening, no heating, no dust emission. Just a silent pulse and then nothing. A heartbeat in the dark. When I first saw that waveform, I leaned back in my chair and stared at it for a long time. It reminded me of something I once encountered while studying gravitational interference patterns. It was a phenomenon so rare that we assumed it could only occur in collapsed stars or black holes. But here it is, in an object smaller than a mountain, drifting through our solar system like a visitor that doesn't wish to be seen. So where does this leave us? NASA isn't evacuating cities. They aren't issuing emergency alerts to your phones. But behind closed doors, simulation rooms are running day and night. If 3I/ATLAS releases another pulse, if the sun responds again, or if its trajectory shifts unpredictably, then the worst-case models prepare us for indirect consequences. We could see communication disturbances, satellite failures, navigation anomalies, and regional power vulnerabilities. All are unlikely, but all are now officially possible. And that is why NASA prepares, not out of fear, but out of a sense of responsibility to the planet. Now let me leave you with a thought I've had since the beginning of this mystery. Throughout human history, the cosmos has always been ahead of us, teaching us, challenging us, and forcing us to grow. From Einstein's equations to the discovery of gravitational waves to the first photograph of a black hole, every great leap began with a moment of profound uncertainty. 3I/ATLAS may be another one of those moments. It may not be a threat, and it may not be a warning, but a reminder that the universe is deeper, more mysterious, and far more alive than we ever imagined in our wildest dreams. Perhaps we are witnessing something that has crossed the gulfs between stars more times than we can count and is now passing briefly through our tiny neighborhood, leaving us with questions we are only beginning to understand. So let me ask you, do you believe NASA is right to prepare for a worst-case scenario? Or do you think 3I/ATLAS is simply a cosmic messenger passing through? Tell me in the comments. I truly want to hear your thoughts. And if this journey stirred something in you, that sense of quiet awe we all share, then don't leave just yet. Click the video appearing on your left. It continues this story in a way you will not expect because the universe is changing around us, and together we're finally learning how to see it. The deepening mystery of 3I/ATLAS. To understand the gravity of the situation, we must look at the data points that NASA is currently analyzing. The object known as 3I/ATLAS entered our solar system on a hyperbolic trajectory, meaning it originated from interstellar space. This alone makes it a rarity, following in the footsteps of Oumuamua and Borisov. However, unlike its predecessors, 3I/ATLAS exhibits a level of structural integrity and electromagnetic activity that defies the standard dirty snowball model of comets. When NASA engineers speak of a worst case, they are referring to the potential for the object to interact with the Earth's magnetosphere or the Sun's heliosphere in a way that creates a coupling effect. This coupling could, in theory, channel solar energy toward Earth with unprecedented efficiency, bypassing our natural defenses. The cold eruption theory mentioned in the Harvard leak suggests that 3I/ATLAS might be composed of exotic matter or a form of condensed gas that undergoes phase transitions without generating heat. If such a substance were to fragment near the Sun, the resulting shrapnel wouldn't just be physical rock. It could be a series of gravitational microlenses. These lenses could distort the path of solar radiation, creating hotspots in our upper atmosphere. NASA's current simulations are focusing on how to shield our global positioning system, GPS, and international communication satellites from these potential distortions. While the public remains largely unaware, the level of coordination between international space agencies, including JAXA, Roscosmos, and the CNSA, has reached levels not seen since the height of the Cold War. They are sharing telemetry in real time, unified by the mystery of the silent pulse. This pulse, which occurred just 48 hours ago, has been analyzed by the Deep Space Network. The frequency of the pulse does not match any known natural astronomical source. It lacks the randomness of a collapsing comet core and the regularity of a pulsar. Instead, it possesses a mathematical complexity that some cryptographers suggest resembles a handshake protocol. If 3I/ATLAS is indeed reacting to the Sun's magnetic field, the question becomes, is this a biological reaction, a mechanical one, or a purely coincidental physical phenomenon? NASA's scenario group is currently debating if the object should be intercepted. However, any attempt to move closer to 3I/ATLAS could potentially trigger another pulse. And with the Sun in a state of heightened solar maximum, the risk of a secondary solar response is deemed too high. As we watch 3I/ATLAS continue its journey toward the inner solar system, the scientific community is divided. Some argue for transparency, believing the public should be informed of the potential for infrastructure disruption. Others argue for caution, noting that the worst-case models are still just models, projections of what if rather than what is. But regardless of the outcome, the presence of 3I/ATLAS has fundamentally changed our relationship with the stars. We are no longer just observers. We are participants in a cosmic event that spans the vacuum of space. The heartbeat in the dark is a reminder that we are small, yes, but we are also capable of witnessing the impossible. As the object makes its closest approach to the Sun, all eyes, both human and robotic, remain fixed on the dark, waiting to see what the next pulse will reveal about our place in the universe. The preparation for the worst case is, in many ways, a testament to human resilience. We build models for what we cannot see because we have learned that the universe rarely gives us a second chance to be ready. Whether 3I/ATLAS is a harmless rock with strange properties or something far more significant, the lessons learned during these 9 days of uncertainty will shape the future of planetary defense for generations to come. We are learning that the silent questions of the universe often require the loudest response from our collective intellect and spirit. As we move forward, we must remain vigilant, curious, and above all, united under that same fragile sky.